All right, guys. Right. So the idea is this: for this plan and design lab, which you must have, well, a minimum of 3 for your total SBA. This is your first one for physics, and of course, those who do chemistry will have one already. But I should point out to you that and I think I said it before that one of the plan and design lab, let us say you did one in chemistry and you carried it out, then well, I was actually told that both the plan and design and the lab that you carry out could also be used for physics if you did it in chemistry. So basically, it saves you doing a lab in chemistry and yeah, going all out with it, because like how this is a plan and design lab. After you finish write it up, you have the option to carry it out, and then that will become another lab. Everybody understand what I'm saying? Like,
Yes, sir.
Yes, sir.
all right, good. So yeah, it's gonna become another lab. So and once you carry it out, then your grade will be doubled in the sense that you don't have to do it again for the other science subjects. All right. So which when you look at it, it gives you a lot of options here, because like the more you look chemistry and you do physics. Kayla, you do physics? No, you do chemistry as well. Can't remember. I know, Michaela, you do chemistry and physics, right?
Yes, sir.
Okay. So yeah, this would apply to you. So you can choose one of the P&Ds to carry out. All right. And that would share for both subjects. You also do bio, Michaela?
No, sir.
Okay. That's all right. And that it would have also applied to bio if you did bio. But all right. So this is it, guys. Let's talk through this lab. Let's show you how to get the 20 odd marks that this lab value. All right. So I was saying before, the problem is that a student, I just noticed that a ball doesn't rebound to its original height, and then um they want to explain or to test why that happens. All right. And the first thing you do with a plan and design lab, if we go back, if you look at this carefully, in fact, let us put today's date on the lab. Today is the 10th of April. And all right, and this will be a lab 4 on paper here. All right. But yeah, the ball not rebounding to its original height. And there are 4 hypotheses. These are pre-constructed, and this is to help those who doing the first plan and design lab to see what a hypothesis should look like. All right. It should be, you see how simple it is. It's like a sentence, nothing too long and wordy. You just get to the point. That's what a hypothesis is. All right. Um, let me just point out to you, or rather show you a hypothesis, a proposed explanation for an event. That's the idea of the hypothesis. All right. Proposed explanation. So it seeks the sentence supposed to explain why the ball does not rebound it. And then it's your opinion, but it's a proposed explanation, right? So it don't have to be right, just has to be you call it now. It just need to be strong, it needs to be assertive. So it's kind of like if somebody asks you a question, it's a yes or no question, and then you're trying to beat around the bush, you know. Um, yeah, you don't want to do that. You want to go straight, and so that's a hypothesis. No, it's not. It shouldn't beat around the bush. It should just be straight to the point. You know. All right. So I'm good with that then. So then let's look at the first one. Ball will rebound to, and let's take out some of this. Oh, there's a typo here, to lower heights when released from a measured height. Okay, cool. So like you measure the height from where you're going to release a ball from. Notice I didn't say throw. You're just going to release it. So you're going to hold it up and just release it. All right. So I don't have a ball anywhere in this room. And we could find something. Um, but you release it means you're going to drop. Imagine that this is a ball, I mean, here it is. And then you just release it. You know what I mean? And this is a piece of metal. If I release it, might break something. So I won't do that. But let's imagine that's a ball. All right, let's find something plastic. Um, I want, I want to show you what releasing is different from throwing. All right, everybody can see this object I have before you.
Yes, sir.
All right. So it's all right. So I'm gonna release it. Notice that I just release it. Let's release it. That's it. That's releasing. All right. So that's what you're gonna do. And I'm gonna show you it because if you were to carry out if you decide to carry out the experiment, that is what you should do. All right. So release the ball, not throw it. All right. So the first one, ball will rebound to lower heights when released from a measured height. All right. So we imagine you in this situation here with the ball. This student who carried out a similar activity actually just where they use a ladder and they release it from there and then measure the height that it rebound to. So that's there. All right. Anyway, so let's go back to this. So you have an option here. Will anybody be choosing to do number one? Number one concerns of football. Anybody feeling that one?
Yes, sir.
All right, Dwayne says yes. Very strong resounding yes from Dwayne. All right, so you have a football at home, Dwayne, right?
Yes, sir.
All right, good. And it pump up or it's off?
Pumped.
Okay, good. So you're good to go here. All right, something you can do at home. Anybody else? Michaela, Deborah, Kayla, Benito. Well, Benito probably
No, sir. Two.
two. Okay. Deborah is feeling the second one, which is a basketball. All right. So yeah, that can work. Basketball will rebound to lower heights when released from a measured height. Okay. That sounds good. Um, sounds good.
Sir, because I did that one before.
Oh yeah, I remember when you're a little girl, you did this one. Yeah. All right. So
Sir, I'm still
yeah.
one.
All right, you're still on. All right, you didn't look so little the last time I saw you though. But I mean, I guess that's the Lord's blessings anyway. All right, so you're gonna do that one. The basketball. You have a basketball at home, Deborah? All right, you have access to one. Okay. Let's see.
Yes, sir.
All right, do. All right, good. All right. So let's try that then. All right, work with that then. That's your hypothesis. All right. Third one says tennis ball. Let's put in the right word here. Tennis ball. A tennis ball will rebound to lower heights. And let's take out the articles here. The article is not necessary. And there you go. So basketball will rebound to lower heights when released from a measured height. And the third one says a tennis ball will rebound to lower heights when released from a measured height. All right. Anybody feeling this one? Kayla, Michaela. All right. So let's write the names of the persons who have selected so far. All right. And so we have Dwayne. And also we have Deborah. All right. Nothing here. Nobody else. Michaela. All right. Number 4 says rebound height of the football. Yeah, if a football, a tennis ball, basketball varies with the surface used. And number 4 is taking a different approach here. We could see how the surface affects the height to which the ball rebounds. All right, that's an interesting one. All right, no, I know this is wide open for you guys, wide open. Doing and Deborah State in the first two. I mean, you can take it as well, Michaela and Kalia. You can choose the same one as doing or Deborah, as well as you can choose 3 or 4. All right, just good when we have more variety in the experiment. All right, but then that's it. You get 1 mark for choosing that anyway. So you can pray about it tonight and ask God to help you decide if you're having problems there. All right, we can move on to the next one. Next part of this lab is the aim. All right. So anybody remember what the aim is? Yeah. Aim. Usually for labs I give you an aim, but a simple trick to the aim is to just put put the words determine before the hypothesis that you choose. So let's say doing choose the first one. Football will rebound to lower heights when released from a measured height. And your aim now could read what to determine if a football would rebound to the same height, or you could say to rebound to lower heights when released from a measured height. Yeah. You just use back this and put to determine if. So you get the full mark there. You get a mark for that. So you'll be getting 2 marks then for just really doing not much really. All right, so let's put that there. And let's use that like that. And then I'm just going to take this one and put to determine. To determine. Or we could put to investigate. All right, so look at that. We'll just turn this into an aim. Yeah. But you see that?
Yes, sir.
Or we could say to invest. Yeah, go ahead. Oh, I thought somebody was saying something. Yeah. All right. So, all right. So there you go. So that's just a sample here. We're just going to remove this because I mean, you see the gist here. All right, and it's an example. All right. So to determine, if, or to investigate. To investigate if these are words that you put before, your subject of the hypothesis. All right. So 3 marks possibly here, or is it 3? 2 marks, because you get 1 mark here and you get 1 mark for the aim. Then no, we can go to the next part, which is the equipment or the apparatus. All right. So if we are doing this experiment now, tell me some of the things we might need for this experiment.
Ball.
Very good. Most obviously the ball.
So a meter rule.
Very good. Meter rule, you could use that. Meter rule, or what? What if we didn't have a meter rule? What else could we use?
Rule. A regular rule. I don't know. Or tape measure.
Yeah, all right. So yeah, measuring tape then. All right. Let's put a measuring tape there. All right, what else now?
you might use ladder. You can put ladder too.
All right, ladder. All right, let's get ladder. Can get a ladder here. All right. Well, again, that's dependent on if the person have a ladder. Um, yeah, but then you could use a ladder, but it's not compulsory.
Yeah. You can turn up on a wall or turn up on a bucket or on a chair or something.
Yeah. All right. So you have options here. So definitely ball and measuring tape is crucial. Then my question to you is that you have a ball and you have a measuring tape. How you going to measure the rebound height? How you going to know where to measure for the rebound?
Sir,
Yes, go ahead, Deborah.
um, I think when you a marker or something, like
Mhm.
when the ball bounces back up, you catch it wherever it bounces to before it go back down, and you mark it on the ruler or something with a marker.
All right. So it's like you're going are you going to you're going to estimate where it bounces to then?
I guess.
Yeah. All right. So you see, wait, tell me now, you're going to estimate the height of the bounce. That will come under a source of error. Let's write that down before we forget. You get a 1 mark for a source of error here. All right. Estimating the height of the rebound. And in fact, you could say height of release and slash rebound. So yeah, very good point there. And that's good. Getting up mark. You see, every little thing we discuss about this lab today can give you all the marks that you need for this lab. So definitely what you said could work, but remember that there will be some error in that, Deborah. All right. Which once you account for the error, it's okay. You can go ahead and do what you plan to do. All right. So ball, meter rule, measuring tape. Well, you said something about a wall. Or was it Benito?
Yes, sir.
All right. Wall. Yeah, wall will be good. Yeah, wall will be good. The wall now could, as you say, mark. So so you actually said something about marking off something, Deborah. What would you use to mark? Would you use a chalk?
So you can use a chalk, a pencil, anything, a marker.
Are you going to use marker on the people in wall?
Sir,
Hmm?
not really. Doesn't have to be. You can use a chalk or a pencil.
Yeah, as I was sticking to that chalk or pencil because I know you guys could get in trouble for using any other thing to mark on a wall. All right. So yeah, this looks good so far. So if we come up with anything, then we write other apparatus here. But we still not finish it. I still want you to think though what else could be used because if you want to reduce the error in finding out the rebound height, the wall helps. As a matter of fact, let's put that as a precaution. Precaution, it would be that wall and in fact, all right. So yeah, so a wall will be calibrated. And I'm going to use that word. If I didn't know what the word calibrate mean, and like calibrated means like the wall you're going to mark it off. Basically, that's what you're going to mark the different heights on a wall. Calibrate means that you're going to take something that doesn't have any measurement on it and give it measurement. You know, that's pretty much it. All right. So like calibration would be like you coming into school in first form, not having much sense, and then leaving in fifth form with a little bit more sense. It means that high school would have calibrated your brain. All right. So that's basically the idea here. But anyway, a wall will be calibrated to to improve the certainty of measurements. All right, this might sound technical, but it is what it is. Yeah. Just basically saying that it make you more certain of the results that you're going to collect. All right. So just remember that as a precaution. You know, you want the wall there. All right. Any questions here, guys?
No, sir.
All right. So guess what? 3 marks of the diagram here. When you draw the diagram, you're supposed to just neatly show the equipment that you plan to use and how it's going to set up.
Sir, I have a question.
Yes, go ahead, Deborah.
Sir, for the labs, you see, the ones that are not P&D, do the diagrams have to be drawn, or we can use the ones that are on the lab sheet?
Yeah, you can use the ones that are on the lab sheet if it's not P&D.
Okay.
All right. All right. So again, we're looking at this situation. I think everybody seen this?
Yes, sir.
Yes, sir.
All right. So yeah, something like that. And then the calibrating the wall now will give you some options. Let me just show you what the calibrated wall would look like. Yeah, and this will be something like that. All right. So that's it. You know, the calibrating, so so calibrating the wall now would make it certain of the height that you're releasing, and also increase the accuracy of the rebound height. But there's something else you could use that nobody is telling me that would further improve the accuracy. So maybe when we talk through it, then it might come out. All right, so let's continue. Clearly, draw a neat. So you see when them say draw a neat, clearly labeled diagram to show how you will set up your apparatus. This what I show you here can be used. Just label it. Just tell me like and it said neat. This is actually neat. You just going to put you're just going to label this ball, and then this would be the meter rule. You know, that's it. Any questions here?
No, sir.
All right. So calibrating the wall improves accuracy. Accuracy of measurements. All right. So that's a note for you guys here. All right. Now let's continue. We have the method that we're going to have to talk through. Now notice the instructions here. Actually is given. You should be seeing this one. All right. The method. All right. Let me just highlight this one so you can see it on the screen here. All right. So, and save this. All right. So the method for plan and design lab should be in definitely future or past tense, right? All the steps you take or you plan to take to carry out this lab. All right. So bear that in mind. All right. No. So now let me say this now. This is the first method now, guys. And even though you see like 8 space, doesn't mean that you're just going to use 8. Like 8 steps. This is just a guide. So the first step, and this is I could cheat to actually do these labs here. The first step. But you can get the first step, the first thing you're going to write here. It's the easiest thing you could write for the first step.
Sir, the setup for the setup of the equipment.
Okay. Yeah. Yeah. All right. Yes. Okay. So you could write that apparatus will be used, and that's why I give you marks for the diagram, because the diagram will help you with the method. All right. So apparatus will be set up, used as shown in the diagram. There you go. Bam. Then that's the first one. So all right, and let's look at the diagram and see then what we could get from this then. All right, so we have all of these things: meter, rule, ball, and then we're taking measurements here. So after you set it up like this now, what's the first thing you'll do then? What's the first thing you do? Because if you're going to go back to your aim is to really, or your hypothesis is actually saying that in the case of doing zone, he's using a football. So you're going to test the rebound, but the rebound is dependent on the release. So that's where your second method will be coming from. All right. So all right, so easily you could see that a ball, all right, will be released from a measured height. No, this is just keeping it simple. I mean, we're not thinking, not bursting our brains for this. It's there. What was already there. We're just putting it here. All right, so a ball will be released from.
Sir.
Yes, go ahead, Deborah.
Sir, you see, for writing our own hypothesis, can we put what height it will be released from?
No. That won't go in the hypothesis.
Okay.
Yeah.
Okay.
All right. Yeah, that sounds like a method. That's a method. You're getting specific about like the height you're releasing it from. That's the a measure. So like what you just say here, you could a height. So a ball will be released from a measured height. No, you could put that height. Let's say it's a meter rule, or let's say it's 200 meters. Example, 200 meters. They give a example of what that is. Well, that's a very a meter rule is 100 meters, and that's like a yardstick. All right, so that would be like from about well, if it's height wise, but probably not seeing me in the frame anyway. But it's not gonna be a 100 meter. Well, it says should be centimeters, not meters. Sorry, I don't know how 200 meters is very long. That's like probably that's like the Eiffel Tower. If everybody know about the Eiffel Tower, or probably Statue of Liberty. Don't think Statue of Liberty is that high, but yeah, 200 centimeters rather is proposed, and that's like 2 yardsticks. You know, height of 2 yardsticks. Our measuring tape could give you that distance as well. So, you know. All right. So ball will be released from a measured height. Example, 200 centimeters. All right. Then all right, then so what? After it release, what's gonna happen after it release? Or what you expect to happen?
Set a rebound.
Yeah, so definitely going to rebound. All right. So what you gonna do with the rebound? When it rebound, what you supposed to do with it?
Sir, catch it before it goes back down.
Hold on. Hold on there. All right. You got in there. So like you're getting excited here, Deborah. All right. So you release the ball and it's going to bounce, and you say you're gonna catch it.
before it starts going back down.
All right. So you wanna catch it? All right. So when you catch it now, what are you gonna do with it after you catch it?
Sir, you're going to make sure it is close enough to the measuring tape or the meter roll, whichever one is used, and
All
mark
right.
the measurement.
Okay. Yeah, you can do that. All right. Yeah. You can do that. All right. So basically, you have to go hold the ball in position. Then can you alone do that, lab, or did you alone do this, lab? I'm trying to record. The boy, yeah,
Sir,
yeah,
no,
go ahead.
but you can do it alone,
You can? Okay.
So we never do it alone because
Oh,
somebody had
okay.
to hold the ball and then somebody else mark the measurement.
And then it's still, you see, there's some more creativity that you could add to this lab that nobody is. There's another equipment you could bring in to make this lab more creative. And if you don't have a second person to help you, that could be the assistance you really need. All right. All right. So all right, fine. So we definitely then, after we release the ball from the measured height, the rebound, the rebound height then, all right, will then be measured. All right. We could skip out a few things here. We just want to get enough so that it flow really. So the rebound height will then be measured and recorded. All right, that's it. This is simple because what we're gonna do here after this, you're just going to repeat it for different heights. So we could do something like this. Repeat steps. So repeat, or let's say method. And see, this is a lazy way to write it, but then you get you the marks. You're going to repeat method 2 and to 3 for various heights of release. We done the method, guys. We finish the method here. Just one more thing now we need for add though. All right, so we're going to repeat this one, releasing the ball from a measured height. We're going to change its height. And that's why we say repeat methods 2 and 3 for various heights of release. Any questions here, guys?
No, sir.
No, sir.
All right. All right, so that's cool. That's cool. All right, now we're going to close this out now. Then you're going to know results will be in a table. Of course, when you're doing these type of experiments, you're going to use a table, and a table would look something like this. All right, now, and this table is just a suggestion. You could actually draw your own table, but let's say, for argument's sake, you're going to use 200 centimeters. Your height going differ, so we could go down by say 80, 180. I could even go down by, well, I wouldn't suggest 50, but then let's go on by 20, and then it'll be 160, 140, 120, 100, and then of course we have 80. All right, something like this could be used. All right, remember we're here in the release height here. Rebound height, there will be nothing here. This will be blank. So when you're handing in this experiment, I don't expect to see a rebound height here because you don't do the lab yet. All right, everybody understand that? The
Yes, sir.
instruction, yeah. So the
Yes,
instructions
sir.
say here, that write down all the heights you plan to release the ball from. All right. Write down all the heights Yeah, all the heights where you plan to release. Yeah, I think where. Mm, I don't think we need that preposition here, so we could take out from. All right, so that's it. Um, that's it. We cover the method here. Um, I think yeah, we cover the method, guys. All right. So and how much marks the method value? That's what 3. I think it's 3. So if you do up to the method, you're getting 3 marks there, plus the diagram, which is another 3. So that's what 6. Apparatus and aim will give you 2 more. So that's 8, and then hypothesis is 1 more. That's 9. So 9 you get almost half of the marks for just doing that. And then of course the data to be collected. See 5 marks here. Of course, if you're going to change the height, you're going to write the surface you're going to use, right? So the surface you're going to use. All right, tell me some good surfaces you could use to test the bouncing or the ability of a ball to bounce.
Concrete floor.
Yeah, all right. So concrete, yeah, good. Concrete floor. Mm.
Concrete, sir.
All right, concrete. All right, and you could use a floor. Floor could be made from concrete though, but anybody
Like a
here?
tiled floor.
Well, yeah, let's call it tile. Mm-hmm.
Board.
Board, yes, all right. This board you're talking, BORED.
No, BOARD.
Oh, just checking. Stay focused, the board. All right, good. So that's the board. All right, the other one. Body silent. There's
So
one more, sir.
is the ground on a court different from concrete?
It
Asphalt.
depends on which court. Asphalt, yeah. Is a ground and a court. Depends on the type of court. The board.
The one
Depends on the type.
outdoors.
It depends on which court the board.
Oh,
Yes. If you're talking about Belfield High's own, that is concrete. If you're talking about probably Manchester now have Manchester use concrete for one. Benito, how Manchester court stay?
Asphalt.
Asphalt. All right. So wait, the basketball court are asphalt now.
Yes,
Benito.
sir.
Okay. It used to be concrete before. I think they okay, good. Yeah, so those are different surfaces. Remember, guys, if you're changing the height of the release, then you have to keep the surface constant. All right. So if you're starting with concrete, you're sticking with concrete. Don't move from the concrete to the floor and still do the same experiment. All right, that's wrong. All right. So remember, keep the surface. So guess what? That brings us to the variable now. What things we will make stay the same and what things we're going to change. So what we're seeing here for the most part is the constant. What will be kept constant. And we just realize that all right, for Deborah and for Dwayne, the surface will be a constant. All right. Surface use is kept constant. 1 mark for that, by the way. 3 marks up for grabs here. 1 mark for the control part there. And we're looking at the independent and the dependent variable now, right? Independent now is the one that you will be adjusting. Which one will you be controlling now? What is it? You say right, the height, the release height. So that is it, you know. This is simple. Release height. So which other one no? The release height will affect what no? What other height will it affect?
Rebound.
And that's it.
One side.
So you get the 3 marks already for the variables. All right, that's it. Bam, 3 marks just like that. So you get 9 from the first page now. This is another 3 that carries you up to 12. Just by writing this in the column here, you get 5 marks here. The heights there. And so this is it. You get most of the marks of the lab already. Any questions here? Soon done enough. All right.
Sir, can you scroll back up the page?
All right. Sure. Here.
Okay. Okay, sir.
Yeah. So the boy, why you breathing so heavy?
Sir, is the earphone I'm using? The mic is at my mouth and I'm talking.
Yeah. Well, you sound like you. All right. Careful, you know. It's one of the symptoms of the
No,
19.
sir.
All right. Okay. All right. Anyway, we'll get that out of the way. We're going to go to the next part, which is the theory. Theories is like usually you have it in these labs where you just write something that you research related to the lab. So the theory here is just like relevant information. So the aim or the topic for this lab is actually the law of conservation of energy. And then you're gonna just basically write how it applies to the experiment. All right. So state the law and how it will apply. So like you get the state the law, you get 2 marks for that. And then we're going to look at that because we have not done this in class. And then how it applies to the experiment, you get 3 marks here. All right. So what is the law of energy conservation? That's our question to you guys. All right. Anybody have any idea what that is? The law of energy conservation? Anybody? All right.
Sir,
Yes, go ahead.
I think it is it states that the total energy of an isolated item remains constant. Conserved.
So like, it's all like somebody in a college or university, man. The total energy of a what? The total energy of what?
System or something like that.
Total energy of a system, which is listen. That definition is perfect. You know that's perfect. You sound like a UTech student there. But at CXC level, them have a more child friendly definition.
That's why we teach them always give it a hard definition what we don't need.
Yeah. But yeah, that's true. But then because them pushing you guys to be you kind of they're pushing you to a higher level. When you go to university and you say it like that still, Benito, it kind of make you fit in more with the bright people that are there. So there's a place for it. But in terms of understanding it now, let's just get it in a more with simpler words. We're going to say the same thing when you say, but use a simpler way to say it. All right.
You know, you understand, but we don't know what you mean. We don't understand.
all right. So stay tuned. We bring that up on the screen in a sec. All right. So basically, basically it says that all right, that energy cannot be created or destroyed, but that's energy cannot. All right, so it cannot be created. All right, or destroyed. But it's only what or can only, but can only be from one farm to another. That's it, you know, same thing. We just said a while ago, the same thing. Your one is use less words and so on more of a learned person, whereas this one is more wordy but simpler words. Yeah, you choose which one that works for you. All right. And then you work with it for the exam if, in case I ask you for it. But it's a very popular question in exam. Usually I give you a 1 or 2 marks for anyway. So you're going to write it for this lab. You're going to get 5 marks, but 2 marks for the definition stated correctly, and then the other 3 to explain how it applies to the lab. All right. So the law of energy conservation states that energy cannot be created or destroyed, but can, and then can only be converted from one form to another. All right, gonna bring this up on the screen. All right, let's enter, and we're gonna show. I think it's everybody seeing that?
Yes, sir.
Yeah. All right. So that's the definition I'm gonna work with there. For the law of conservation. 2 marks just for stating that, guys, are what Benito said. The total energy of a closed system or an isolated system remains constant. That's what you said, right?
Yes, sir.
Yeah. That would be a CAPE definition. That would be like for CAPE physics. I expect students to state it like that. But for CXC, I appreciate it. If you want to state it like that, fine. You're still going to get your marks. But, you choose total energy. All right, probably even create that banner for that one then. All right. The total energy. The total energy of a closed system. All right, remains. Did you say total internal energy, or did you just say total energy?
Total energy.
All right. So total energy of a closed system remains constant. All right, fine. So anyone probably easier for you to remember. I guess it comes down to that. This is easy to remember though. Yeah, it is easy to remember. Let's press enter here and see what that looks like on the screen. Yeah, total energy of a closed system remains constant. Again, that's another statement. Here, let's edit that one. All right. And again, the law of energy conservation. All right, so all right. Any questions here? You wanna go here, so can move on, right?
Sir, the definition we just right, how we gone?
I'm gonna bring it up back in a minute. Let me just all right. I just want to check if it's now that one.
No, sir, it's simple one.
All right, let's go with that one. This one.
Yes, sir.
All right, so there you go. All right. So once you have that there, we can move on. We can go to the expected results here. All right. So you basically following me up to this point, students, you will be getting most of your marks here. I basically leave with nothing much to do really. So you already passed this lab if you're able to reproduce what I do here. And then no, I will send this I'm going to send this in the group so you can have it to look at. All right. It is expected that the ball will rebound to a lower height each time due to. All right. So I actually started what the expected result should sound like. All right. Expected results is just you predict, you expect, and then what you say a while ago, or not. Well, some time ago at the start of the class, you were saying that the ball you don't expect it to rebound to the same height. So that is 1 mark to state that. That the ball will it's not likely to rebound to the same height due to losses in energy. All right, so this is the reason for it. If the graph is to be, so the graph if all right, so one, if the graph of the release height versus the rebound height is plotted, a straight line showing a negative correlation is expected. All right, you can make a note of that. That's the expected results. Any other thing you think of, you can put it there. But then this is us having a discussion saying that this is true. Any questions here, guys? This will carry us into the treatment of results. All right. Because we're saying that here, results will be used to plot a graph. And that's the treatment of results. All right. Let's draw this properly. So results obtained in the tables will be used to plot a graph. Right? And I hope nobody will ask me how the graph is supposed to stay, because, well, you're not going to plot a graph for this, but you're just going to state that a graph will be plotted. Remember, it's future tense. So you don't do it yet. You're just planning to do it. You're showing me the plan that you have before you actually do it. All right. Now we have one precaution. We have one source of error. So those marks are there already. And the limitation is also stated. Ball will achieve a rebound height for a very short time. So when the ball rebound, you only have a short time to measure it. And so that is a limitation. All right. Again, nobody is telling me the creative way in which we could increase the accuracy or reduce this limitation. So I'll leave you with that. I'll leave you with that to figure out. All right. That's it, guys. We're through. We are through. You're just going finish this up. Remember the 3 marks you're going to get for how it apply. That is something that you guys going to do on your own. Of course, with the diagrams now. Let's look at the diagram on the next page. We could just call it suggested diagrams here. All right. So, any questions here?
No, sir.
All right. All right. So let's get this which is on the screen. Okay, let's hide that one. All right. So that's it for physics class. I use for today. All right. So I know we're supposed to have chemistry class today as well. So that will be shortly. It'll be about 3 o'clock. Or yeah, or 3:15. All right. So